Hello and welcome to this video on using Substance 3D Modeler for 3D printing. My name is David, and in this video I'll walk through how I created a wavy base for Benchy. Benchy is a model commonly used to benchmark 3D printers. If you'd like to follow along but don't have Benchy yet, you can download Benchy from 3dbenchy.com. A link is available in the description below. To get started, I'll import Benchy to a new scene with File, Import Mesh. In the Import window, open the file browser, then navigate to the file and click Open. For this file, the unit scale should be set to centimeters, so that Benchy is imported at a reasonable size. With Benchy imported, I'll start working on the base. The imported Benchy gives an idea of the size the base should be, so I'll create a block to start working from with the default cube brush. I'll use this block as the base for Benchy and carve waves into it using Boolean subtract. First though, I'll hide Benchy so it isn't in the way. To create the wave effect, I'll start by creating a new layer with the sphere. Then I scope out and select the layer. From the Actions menu, I select Boolean subtract and turn on Live Preview. Live Preview lets me see the results of the Boolean operation before applying it, so I can move the sphere around and the Boolean operation is updated in real time. To create the wave effect, I start moving the sphere and tap D to create a duplicate. As more spheres cut away from the base, we start to see a wave pattern form. Once I've got enough spheres to cover the base, I can start moving and scaling individual spheres to get the desired effect. This looks pretty good, so I'll apply the Boolean operation. With the Boolean operation applied, I don't need the spheres anymore, so I'll delete them. Next, I'll bring back Benchy and use the Select tool to move it into a more dynamic position, matching the waves. This looks good, but I still need to create a space for Benchy to sit when the base is printed. I want to use Boolean operations again to subtract Benchy from the base, but the choice isn't available because Benchy is a mesh and not clay. Most of Modeler's tools and actions only work on clay, so I first need to convert Benchy to clay before I can use Modeler's tools on it. With Benchy selected, I open the Actions menu and select Convert to Clay. Benchy is made up of many parts, so it could take a few minutes for the Convert to Clay process to complete. While I'm waiting for the conversion to finish, I'll check that my 3D printer is prepped and ready to print. I'm going to be using blue PLA Plus filament for the base, so I need to change the filament out. Every printer is different, so refer to your printer's manual to make sure you set it up correctly. The conversion is complete, so I'll start making a space for Benchy to sit. I select Benchy and just like before, select the Boolean subtract option from the Actions menu. Click Apply and wait a couple of seconds for the Boolean operation to complete. I need to clean up the result to make sure that Benchy can sit flush in the space that I've created. I'll use the same Boolean subtract workflow that we've been using throughout this video. Quickly create some extra layers to use as Booleans and move them into position. Once everything looks ready, I open the Actions menu and apply the Boolean operation. Then I'll hide everything except the base. Benchy now has a place to sit, so it's time for the next step, export. I'll open the Export menu with File, Export. There are a few settings that I need to change before starting the export. First, I'll change the file format to STL. STL files are commonly used in 3D printing and should be supported by your printer's slicing software. Next, I'll set the unit scale to centimeters to match the scale of the standard Benchy model. 3D printers don't really care about polygon counts, so I'll set the polygon type to raw mesh, as this results in the fastest export and the highest level of detail. Lastly, I'll turn off Export Hidden Content, so that the Benchy layer that I hid earlier isn't included in the export. Finally, click Export to select a file name and export location. The last step is to convert the exported STL file into a printer-readable format. This step depends on which printer and slicing software you're using, so I won't go into too much detail. I'm printing with the Bamboo P1P, so I use Bamboo Studio to prepare prints. For this model, there aren't any overhangs or complex geometry, so I've turned off supports. I'm printing with a 0.12mm layer height, which serves as a good compromise between detail and print speed. Once I'm happy with my settings, I click Slice to generate the paths that the printer will take. If you notice problems in the generated paths, you can go back to Modeler, make changes, and re-export your file. Once I'm ready, I'll send the print directly to the printer from Bamboo Studio. Uploading the file to the printer again depends on your specific setup, and could require a USB flash drive, an SD card, or other software like Octoprint. Once the file is uploaded, start the print and enjoy seeing your creation come into the real world. When the print is finished, I remove it from the print bed and check that my nearest benchy fits comfortably in its new home. And that's it. Let us know in the comments below if you'd like to see more videos on 3D printing with Substance 3D Modeler. You can also check out the links in the description below to join the community and share feedback with other Modeler users and the development team. We would love to see what you create and print with Modeler.